then if you have any questions from the previous session before I go ahead and explain where we winded up in the last session. Does anyone have any questions?
No.
No. Okay. So before going ahead, I'll be asking few questions, and then I want you to recall what we looked into in the previous session, and then tell me about job tracker. Okay, Mansa, I'll just explain you what the job tracker. And the task tracker once again. Okay, I'll explain you. So Mansa says she wants to understand the job tracker and the task tracker once again. Sure, definitely I'll explain you. And so Narsima and Zubair, do you want to tell what is job tracker or what is task tracker? Sorry, Narsima and Gautam.
Yep.
Sure.
You are asking me or you are telling me?
I'm asking, do you want to explain what you understood, what is job tracker, what is task tracker?
Like job tracker is which contains all the jobs. It assigns it divides the job, it takes orders from client and then divides it and give to task tracker.
Yeah, I think that's a good answer. Good answer. Then Narsima, do you want to add anything? Looks like Narasimha is not able to speak, or there's problem with his mic or something. Okay, so let me share my screen and then explain you in a little bit more detail. Just give me a sec. You can see my screen, right?
Yes, and like I need to ask one thing. Is anyone recording this call?
Yes, I'm recording this call for Zubair, and I'll be sharing it with just explicitly within the recorded session. If anyone else want, do let me know. Sure.
Yep. Thank you.
And do let me know if you can see a screen where where there is a slide talking about the job tracker. Just ping a quick yes or no.
Yes.
Okay. Okay. Fair enough. So Mansa, I'll just repeat it for your interest, so that you are also in pitch with all the others. There's something called job tracker, there's something called task tracker in the system that I hope you understand. And so what happens up is when the user submits the task to your distributed file system, what he does is first copies the files, the data files and the logic which need to be ran on the system. And after that, he submits the job to the task tracker. What task tracker does is, task tracker retrieves the information about the splits. What splits are, I'll be explaining in some little time. It retrieves the information about the splits and submit the job to the corresponding task tracker. There are individual task tracker running on data nodes who are maintaining the task which need to be run on a particular data node. So there is a dedicated task tracker for a dedicated data node. There will be always one task tracker which will be running. There will be always a one task tracker which would be running up and would be maintaining the jobs which are being ran on the data node. Till now it's clear, Mansa? Just a quick yes or no. Okay.
Yeah.
After that, now the client has submitted the job to the task to the job tracker. Job tracker has what job tracker does is it's put the task which need to be read in something called job queue. and also reads the files. The file over here which I am telling about is the logic, the code which need to be ran on the data from the distributed file system, because that logic is also lying on the distributed file system and the data is also lying in the distributed file system. And create your map and reduce program which really run and do the processing of the data. So over here, number of inputs is equals to number of so over here, number of maps is equals to number of splits. Again, it's something related to split. I'll just explain in a minute. Then what happens at the over there a bit between the between your task trackers and the job tracker is task tracker keep on sending the heartbeat signals to the job tracker. Here the job scheduler is a process which is running, and you can assume it's similar to job tracker. Job tracker. And this scheduler basically picks on jobs in the queue which has been placed over here, which are seen in this screen, and basically initializes those jobs and assign those tasks to a task tracker. And those task trackers which are running on the data node then run those tasks. Is this whole picture clear?
Yeah, but what's the difference between job and task?
Okay. Okay, good question. Just a sec. Okay. You are able to see my screen, right?
Yeah, I can.
Okay, so I'll just opening an Excel sheet just a minute. Just a second. Just trying to find out where to from where to share the Excel. Just a sec. So I hope you can see an Excel sheet which I was explaining that day on the screen.
Yeah.
Okay. So what happens is now say I have a file which contains orders and say it contains order IDs. Okay. So this is a file which contains which is split into 10 blocks. So 1 to 10 blocks. So if it's split into 1 to 10 blocks, it would be available, a copy of each block would be available on separate data nodes. So say the 10 blocks are distributed something like this. I have not highlighted all the 10 blocks, but block number 1, 2 and 5 are equally distributed, visible on this screen. Rest or other blocks are also similarly equally distributed across all the 5 data nodes in the system. Hey guys, I'm making you all on mute. Whenever you have to speak, I'll just make you unmute and you can speak on the air so that there's no disturbance, and you can just ping me on the chat window. So say this file contains order IDs. This is a file of Amazon orders, say, and this contains order IDs from 1 to 1000. And say block number 1 contains order IDs 1 to 100, block number 2 contains order IDs 1 to 100 and 1 to 200 and so on till 10. So it contains 901 to 1000. Now these are the blocks. And this is the data in those blocks. Okay, and what my logic or what my code need to do is figure out which are the blocks, which are the orders which are greater than 1000 USD. So I'll be writing a logic something like this. As a client, select star from order where order price is greater than 1000 and selecting order ID. Okay, once it's clear now till now, just click yes on the chat window. Yeah. Okay. So what I have to do is what I'll be doing is I as a client I'll be sending a signal to my job tracker and will be telling him to run this job. So I'll be sending this query as well as the query to this job tracker. So this query has been sent to the job tracker. Now job tracker task is to run this query on all the data for this file F1. But this file is distributed on 5 different nodes. Oops. This file is distributed on 5 different nodes in 10 blocks. So, and these are the nodes on which file is distributed. So when I am running the query, I need to run the query on individual blocks. So when I am running the query on individual blocks, I have to ensure that the query is not ran on duplicate blocks, as well as the query is ran on all the blocks, and the output of the query from each of the blocks is properly segregated and everything is done. And as me as a client will get only the order IDs which are greater than 1000 USD. So what job tracker will do is will assign this this task to the corresponding task trackers, and there is an individual task tracker for each data node. There is a task tracker which will always be running on the data node and which is always sending the heartbeat signal to your job tracker. So if the task tracker fails to send the heartbeat signal to job tracker assumes that the task tracker is down, and the task which I have given to this task tracker to find out the order IDs is not being done. So now I have to assign the task to some other task tracker where the duplicate data for those blocks is lying. So now for a time being, this is red. I'll make it a default color, and then we'll talk about that part. So what task tracker will do is will send this task to all the task trackers on these data nodes, and will ensure that this task is ran for all the blocks for this file. So when the task is sent to this task tracker, which I'm pointing right now on the screen, it will run it for blocks 1, 2, and 5. And similarly, this task tracker will run it for blocks 6 and 8. 1 and 2 are already taken care by data node 1 task tracker, and so on. So, okay. And I hope it's clear till now to everyone. Okay, everyone say the good yes. Now say what happens up is while this task tracker is processing the data for block 1, 2, and 5, there is some problem with the network, and now hope you understand this, that the hardware you cannot stop hardware from failing. And we have seen this thing. So say this task tracker stops sending heartbeat signal, it crashed or something has happened to this network, and it has stopped sending heartbeat signals to your job tracker. Now this was supposed to give me some IDs, that is order IDs. The output of this would be something like order number, what was it over here, order number this to this, and so these are the orders from 1 to 100 which are greater than 1000, and these are from 101 to 200 which are greater than 1000, and so on for fifth also, say 501 and 559. Okay, so this task tracker was supposed to give this output, and this output then need to be consolidated somehow and need to be sent to the client. But now this task tracker is down. This task tracker had not sent the heartbeat signal to your job tracker. So now the job tracker job was to get the job ran successfully for all the blocks of the file. So in that case, what job tracker will do is will communicate with the name node and ask with the name node that, hey man, I need the information about these 3 blocks of file 1. Where is a duplicate copy of these 3 blocks lying in our system? So name node will return the address of the data nodes where the duplicate copy of 1, 2, and 5 are lying. So say 1, 2, and are lying on data node 2. So it will return to him data node 2 for 1 and 2 blocks, and 5 is lying over here, so it will say data node 4, data node 4, data node 4 for block number 5 to the task tracker. So what task tracker, to the job tracker. So what job tracker will do is, will again create process, two more process to run, and the process would be nothing but the select query, and will trigger this process on these task trackers also for these blocks. So this is how the hardware failures and network failures are basically we can take care of hardware failures and network failures with the help of this kind of scenario. So job tracker task is to complete the whole job. It maintains, it manages the whole job. It is like a monitor of the whole process. However, task trackers are individual worker nodes which are doing the real work. Mansa, does it make sense now? A quick yes and no from everyone. Mansa says yes, Nasima says yes, and Gautam also says yes. Great. Now, few more things. Now say the data node is down. Rather than a task tracker, data node whole has gone down. Is data node has gone down. Now what will happen?
Raj, one more thing.
Yeah.
Like it's like task tracker has a task which is to be done and the work is done in data node. Am I correct?
No. Task tracker is running on the data node only. So it's something like this. The system looks something like this. Say this is your data node, and let's give it a beautiful color. Say this is your data node, and this is how different data nodes are there in my system. This is data node. This is the data. This is the data node, and your name node is sitting on top of the system, which is managing the whole cluster. And let's give it. I'll give it a different color to this because this is the monitor of our system. Monitors whole system, and just keep on talking with these data nodes. Okay, so on the data node, there is a data line, as we talked over here. This data is line. So there is a data line on these data nodes, as well as processes are running on these data nodes, and the process which is running on this data node is called your task tracker. Make sense? This is how the data nodes look like.
It's like simple. In the data node, task tracker does its work.
Yeah, task tracker is a process. So like this is a Windows, and there are a lot of processes running on this Windows. Similarly, there is a process which is running on the Windows and getting the data from the system and doing all those things. Same thing is happening over here.
Okay.
A process is running on the data node. Data node is nothing but a machine, your Linux or Solaris or whatsoever box, and there are processes running over there. And one of the processes is called task tracker, which is really running the task for you. Getting the picture of the system?
Yeah.
Okay. So clear with everyone? I'll be asking few questions now, and I want you to answer those. Okay. No response means everything is clear. Either cluster clear or everything is very clear. So now say this data node 1, this data node 1 is down. This data node has stopped sending signals to your name node. This data node is down, and my job is running. Before that job is running, what will happen when this data node is down?
The same way as you said, as task tracker.
Task tracker. When my Windows system is when my laptop is crashed, nothing can job tracker, task tracker, everything is down. Whatsoever was running on that system, the process is down.
Oh. Yep, I'm just saying as the work of task tracker is divided by other task trackers. The same way the work of this data node will be shifted to other data nodes.
Yeah, but how that will be done?
Like as the name node knows what all the data is there in the data node.
Yeah.
So job track, I think I guess job tracker will be, it will be saying to job tracker that this data node is down, this has this data, so that job tracker can reassign those data, work on that data to other task trackers.
So the Gautam, there's one more beautiful thing in the system is the task tracker is running as a separate process. So job tracker is running a separate process. So job tracker don't have to worry from the name node to get the information about the data nodes up and down, up or not. So because task tracker keep on sending signals to the job tracker. So if this whole node is down, there will be two things. You were I would say 99% right, but there's few more little bit more things. So what happens is when this whole node is down, that is the hardware itself is down rather than the task tracker, the process which is down on your hardware. So what will happen is first thing is name node will not get the heartbeat signal from the data node. So data node sends heartbeat signal to name node and the process, the task tracker, sends heartbeat signals to job tracker. So there are two kind of heartbeat signals which are sent from the same system. One is the hardware signals which tells the hardware itself is up, and one is the process signal which tells this process is up on this data node. So when the hardware signals are down from this data node 1, the first duty of the name node as a coordinator of the whole system is it will try to maintain the replication factor of the system. So what it will do is it will assign the task to data node 2 or 3 or whatsoever where this data is lying, that please replicate the copy 1, 2 and 5 to the so and so data node. So if say a copy of block 2 was available over here, and the third copy is lying somewhere in the system, I don't care about that. So name node will give a signal to data node 2. Hey man, data node 1 also contains a copy of block number 2, but it is down. Please copy this block number 2 to data node 3 so that we maintain the replication factor of 2 in the system, and 2 will send the copy of block number 2. Okay. 2 will send the copy of block number 2 to data node 3, and data node 3 will copy that thing in itself. So this is the first and foremost thing which will happen in the system, so that the integrity of the system, replication factor of the system is not hindered. Then at the same time, job tracker will also stop receiving the signals from task tracker because the whole hardware is down. So job tracker will check where the other copies of 2 are lying. Till now, the third copy of 2 has not been pasted to data node 3, and job tracker does not care about it. Job tracker will not wait about it to be done at the backend. That will be done all at the backend, transferred to your job tracker. But job tracker will get an information from the name node. Yeah, that data node 2 is the correct location where the copy of block 2 is lying. So I can assign the task to data node 2 to run for order IDs 201 to 300. Getting it? Any confusions? Anything?
Yeah, we got it. Like I got it.
Okay. And Nasim also says yes. Mansa? Mansa says no. So Mansa, I'm just bringing you on air. Just do let me know what are your what are your confusions, and we can talk about that. Hi Mansa, you are on air.
I mean, I said no confusion.
Oh, okay. Okay. So this is a problem with general English. Okay, good. So this yeah. So everyone of you belong to India. Probably, I think this is your mother country. Any one of you understand Hindi? Sometime I just in the flow I just pop out some Hindi words. Does anyone understand Hindi, or answer yes? Nasima says okay. Okay, Nasima, no worries. You can just type on, and we'll take care of that. Don't worry. Okay, Narsima says okay. Narsima, you can just type out. So sometimes okay, cool if you understand. So sometimes some of the feeling really comes when I talk in that particular language. But when there are a lot of students from USA and who are native US citizens, then that case it creates issues. But I love to give some things which you really give a great feeling in that language. So now everyone understand heartbeat signals. Data node sends heartbeat signal to name node. Name node uses the heartbeat signal to detect the data node failures. I am not wasting any time on the slide, and it's crystal clear with everyone. Replication engine. Data node detects data node failure, chooses the, this also everyone now understand how the replication engine works. As the failure happens, the signals are sent, and this is how the replication factors, and the replication factor of 3 is maintained in the system. However, the replication factor of 3 is configurable in the configuration files. We'll be looking into them, and that is how it is maintained in the system. So now let's see how the write happens in the system. Now we have seen how the job are processed in the system when the data was really lying in the system. But before that, we have to copy the data into the system. So how the data really copied into the system? Me as a client will send the signal to name node that I want to add this data to the SDFS cluster, Hadoop distributed file system. So I'll send a signal. Now my whole file is divided into blocks, so I'll be talking everything in terms of block. So I as a client will tell name node, hey man, I have to write this block to the system. Please help me out in writing it. So as I told you, name node is the most precious infrastructure of the system. So we don't want to waste the precious CPU resources, the precious hardware of the name node in doing the mundane tasks. So name node will not waste its signals or waste its processing and capacity and resources in doing the mundane tasks. So by mundane tasks, what I mean to see, the tasks which can be easily done by data nodes or the worker nodes, name node will not waste its resources in doing those kind of tasks. It's the precious resource of the system. So the memory and the resources of this name node has to be precisely used. So what the name node will do is name node will just send a signal to your SDFS client, the client which is trying to write the data, that go and write the 3 copies of this block to data node X, data node Y, and data node Z. And then it's the client's responsibility to give a write signal to those data nodes in the fashion in which the node has told. And name node work is done. Name node will not do anything other than that. So name node is a monitor. It will just monitor the system and it will give commands. So SDFS client will then talk to that corresponding first data node which name node has given to him and says the right signal to that data node and tell him, yeah, this is the data, please copy it on you, as told by the name node. Then that data node will copy that data into it. Now after that, what will happen? A quick answer from everyone. We talked about this in one of the previous slides where some stars were popping up. We were trying to copy the data into 3 different blocks. Now what will happen? I'll just ask the question. I'll just repeat the question. Now SDFS client has sent the write signal to first data node. Now will the SDFS client will send the write signal to the second data node or something else will happen in the system?
Like it sends information to name node that which blocks are entered into the data node?
No. I'll repeat my question. My question is, SDFS client has given the write signal to first data node. So name node has given these 3 data nodes, data node X, data node Y, and data node Z, where the block need to be copied. Me as a client, I have given a write signal to the first data node X. After that, will I be giving a write signal something like this? Something like this, a write signal to this data node and then a write signal to this data node. This is one. Or this data node will be giving the right signal to this data node, and then this data node will be giving the right signal to this data node. This is 2. Or this data node will be giving right signal to this data node, and this data node will be giving the right signal to this data node. This is 3. I need a quick answer from everyone, 1, 2, or 3 from all 3 of you.
Like 1.
So who said 1?
Gautam.
Gautam says 1, Mansa says 1, and Narsima, you can just ping on the chat window. Mansa says any of the 3. Okay, Mansa says any of the 3. Narsima, we are waiting for an answer. Narsima says 1. Okay. So all of you are wrong. All of you are wrong. Narsima says 1. Gautam, did I got an answer from you?
Yeah, 1.
Okay. Okay, let me go back to the basics. Why I was copying the first block on rack 1 and then the second and third copy on different rack.
Like if in the first rack is gone, the second rack will be useful. And why we have 2 copies in the same, because like in order to save from second rack to third rack, it takes more some like power or some things, so we'll be on the same.
Yes, Gautam, that's a perfect answer. Now again my question repeats on the same slide. That's a perfect answer. Now again think over here and give me the correct answer. One, 2, or 3. We are saving time over there in data copy. And that's the reason we copied the second and the third replica of block 1 on the rack 2 only.
Instead of 1, it can be 2 or 3.
Yeah, that's much correct answer. But again you think and then you will give me the perfect answer. We were saving
1, 2, 3, like because the new copy will be sent from client and replicas will be created between data nodes.
Yeah, then so what will the correct answer? 2 or 3?
All 1, 2, 3.
No, if I do 1, 2, 3, then your client is sending the data again to data node Y and data node Z. So say this is Y, and this is Z, and this is X. So if say client is sitting on rack 1, and then the data node X is on rack 1 only, but Y and Z on rack 2.
Okay.
Nasima, Mansa? Okay, Mansa says, can you repeat the question? Mansa, my question is, there are 3 ways in which I can copy the second, I can do the second copy in the system. So first copy was sent from the client to the data node X, which was lying on the same rack where my client was sitting to save the network time. Second and third copy will be copied to different racks, say rack 2 on, and these data node Y and Z are lying on rack 2. So the thing between purple color is rack 1. Rack 1. This is, yeah, I hope this is clear with everyone. This would be in the different rack. If you have questions on this also, then I have to repeat this slide. Now, to save the network time, what we were doing is we were sending the these second and third copy on the same rack. So what could be the writing structure in the system? Either the one which I've highlighted on the screen, the 2 that is data node X is sending 1 copy to Y and second copy to Z, or the third that is data node X is sending the copy to data node Y and then Y is sending that copy to Z.
Like first it writes, and for the other two, the first data node only will be giving the data to other two nodes.
Okay. You're partially correct. Let me tell you. Okay. So what will happen is data node X will send a write signal to data node Y, which is sitting on different rack. So now there is a network bandwidth which is consumed. Data transfer was slow from X to Y, but we have to do that to maintain the system, and then the data is properly distributed across the system. Then if X would be sending, so the probability of 1 is all gone. 1 will not happen, definitely. The answer 1 was totally incorrect. Then if X would be sending this data to Z, in that case again I'll be doing a rec transfer, and this will be slow. And that is the reason the copy of second and third blocks were available on the same rack. So what will happen is Y will send a write signal to node Z, and the acknowledgement from Z will be given to Y. Then the Y will be sending the acknowledgement to X, and X will be sending the acknowledgement of client, and client will be sending that write is complete to the name node. Now name node knows that the data is written properly on the 3 different data nodes, and now name node has the metadata, will update its metadata that this block of so and so file is available on these 3 data nodes. Clear? Any questions? Gautam says no questions. Actually, just yes and no are a little confusing. No might means not clear, and no might means no questions. So Gautam said no. Now it says no questions. Okay. Mans also says no questions. And Nasima says, is it 3, 2, 1 communicating with the client? No. Narsima, it's not 3, it's not 2, and it's not 1, it's the 3, the data flow is. So let me clear the screen, and that will give you something somewhat better. So okay, leave it. I'll not clear it. So what will happen is just look at the PPT and whatsoever is written by hand. So don't worry about it. So what will happen is when HDFS client will send a signal to name node that I want to write so and so data block in the system. Name node will return that go and write it on data node X, Y, and Z, where X is lying on the same rack where my client is sitting, and Y and Z are lying on the same on some other rack. So to maintain that if the rack 1 goes down, at least the data is available on rack 2. So LGFS client will then send a write signal to the data node X. Then data node X will send a write signal that is copies the data from the data copy which happens from data node X to data node Y, which is on separate rack, and this will be a little slower. And then the data from Y would be copied to Z rather than X sending the data to Z, because again that data transfer would be slower because that would have been on the rack over the racks. So this is how we save the network time and distribute the data across the system, and that is the reason that the same copy of block, the second and third replicas of block are copied on the same rack rather than sending it to the third rack. If I were send it to the third rack, then again this third data transfer would have been slower. So that's the reason the second and third copy on the same rack, and this is the reason behind that. Nasima, clear? Okay, so it's clear with everyone. If anyone has doubt, do ping me on the chat window. Otherwise, I'll be going ahead. Okay, so and then the acknowledgement will be sent from Z to Y, Y to X, and X to client, and client will be sending the acknowledgement to name node. Now say in this write process, when X send a signal to Y and Y send a signal to Z, in between this beautiful guy Y, which class should, okay, this beautiful guy Y gone down, hardware will always fail. You cannot stop the hardware to fail. So screen is getting a little meshy, but please bear with me. Now Y has gone down, and as acknowledgement was sent from Z to Y, Y has failed, and X will not get to know that the data is copied to Y or Z. Then what will happen? Any quick guesses?
as there is no acknowledgement, they'll get to know that there is the data node.
Yeah, that they will get to know, definitely, that X will get to know. But then what will happen in the system? So in some of the systems, now I'm going a little bit more deeper. I'm just helping you in some of the questions which you might face in the interviews. So that's the reason I just pointed out, because interviewer will not ask the simple question how the write will happen. He will ask the second gone down. So what happens in some of the systems is there is something called minimum replication factor, which is considered to be right to be successful. So if the minimum replication is set to be 2, which says the write is successful, then in that case the acknowledgement from Z will be when Z will try to send acknowledgement to Y, and if Y is down, what Z will, because Z knows that the data is coming from X to Y and Y to Z, this whole thing is available with Z also, because the data came from this cycle. So the Z will send an acknowledgement to X, because Y is down now, and then X will send an acknowledgement to client, and now client will send an acknowledgement to name node. Now name node knows that this data has been copied to X and Z, and it's not been copied to Y. But if the minimum replication factor, which is considered to be safe write, is set to 2 in the system, name node will say okay, write is done, and everything is fine in the system. But if the minimum replication would have been greater than 2, then name node would have given other data nodes to the client, and then client will again keep on writing to those data nodes. And what at the backend will happen, but the replication factor in the system is set as 3. So what at the backend will happen is name node will then send a signal to data node X or Z somewhere, sometime at the backend, and will tell them to replicate that block to some other data node M or N, and that will happen at the backend. So this is how, again, hardware failures are being ignored or are being beautifully transparent to the system. A replica of Y will be created. Y is the data node Narasimha. So Narasimha says a replica of Y will be created. Narasimha, Y is the data node, but the copy which has to be copied on Y is not copied because Y itself has gone down. So if the minimum replication factor, which is considered to be a safe write, is being set as 2, in that case this write will be considered as a complete write, and at the back end name node will take care. In the same fashion, when some node has gone down, then the data need to be replicated. In the same fashion, this scenario would be taken care at the back end. But if say Y and Z both have been gone down in this whole process, in that case, when data node X will send a signal to the as client that data has been written, but only on the data node X, then when this client will send a signal to name node says, no, I cannot consider this is a complete write. Please try to copy this on data node X and data node new 1X, some other data node also. So there's some other data node also, and then again that whole write process will happen, and then the complete signal will be sent to name node. Nasima, is that clear to you? Okay, now Nasima says yes. So I'm going ahead. Mans also says yes. Okay, cool. So this is called a data pipeline. What I have explained in the previous slide. This is called data pipeline. It's all written over here. What I said in the previous slide. So you can just read if you want to. But this is what I explained in the previous slide. Now how the write happens on the data node on the cluster. Sorry, how the read happens on the cluster. So when me as a client, I'll be asking again the name node, hey man, I need these blocks, please let me know where the blocks are lying. Name node will return, yeah, the copy of this block is lying on X, Y, and Z. I will send a read signal to data node 1. If by somehow the data node 1 was not able to give the block to me, then I'll again query the name node. It will give me another data node with the replication lying, and I'll read from there, and so on will happen. So this is how the read happens on the system. And name node will beautifully and intelligently return the data node which is nearest to the client, so that the data transfer is least in the system. So if the client is sitting on rack 1 and the data is available on same rack, the BAME node will return the data node on the same rack rather than returning a data node which is on some other rack to save the network bandwidth. And if the data is lying on the same node where the client is sitting, name node will intelligently return the same node rather than giving us a different node on the same rack. So this is how data transfer is reduced across the system. And our system is very fast. Clear to everyone, please? Yeah. Okay. So there is something called checksum also, which is taken care in the read. What is checksum? Checksum is nothing. It is a kind of what I should say. Okay, 1 minute. I hope you can see my screen, the Excel sheet. If not, just bring me on the chat window. So say this is my data. This is my data in the block. Okay. So what will happen is, this is my data, and there will be something called header with the data also, and there will be something called footer with the data also. So anything beyond these pipes are header and footer. So header will contain something like this, and this is my data, and footer might contain depending on the file structure and number of things. It might contain it, there might not be any footer, but there will be something called header also. So what is this header is? Header is nothing but is a kind of checksum. Checksum is nothing. There could be some logic which will be doing checking, counting the number of bits in the system. So number of bits would be, so if if I represent D in ASCII, it will be 34, 34, 64, whatever D value is. Then F would be somewhere 65 or 68, and so on. So checksum would be nothing but the sum of all these things. So here checksum would be somewhere around 3000 or something. So what is this checksum is on this screen? So checksum is nothing but the computation of the bytes, and by the help of checksum, system gets to know that the data which is transferred across the network which I have received is correct by checking the data with the checksum in the header of the data. So this is how the data correctness happens in the read cycle of the system. So this is all about the basics. I'll be moving on to the MapReduce part. Any questions on whatsoever we have discussed till now? Name node, data node, job tracker, task tracker, read anatomy, write anatomy, how the system is fault tolerant, how the system is scalable, what is parallel processing, what is Hadoop, what is distributed file system. Any questions on any of these terms? Read. Okay, Narsima says he has question on the read anatomy. Yeah, Narsima, please write out a question. What you want to ask? Okay, Narsima says he want the read anatomy to be repeated once again. Okay, Narsima, I'll quickly repeat the read anatomy for you. So me as a client, I want to read some block of a file. Block would be distributed to the 3 different nodes. So say it's lying on node X, node Y, and node Z. And me as a client is sitting on rack 1. This is rack 1, and say this is rack 2. It asks, I want to get this block. I don't know where this block is lying. All this information is lying with the name node only. So I, as a client, will send a signal to name node. I want to read this block. Please tell me where the copy of this block is lying. Name node will beautifully return the nearest copy of that block, where that nearest copy of that block is lying to the client. So name node will, in this case, will return that is lying on data node X, and client will read it from data node X. But somehow, when client read the data, there is a failure in the network, data node X got down, or the data which is read is incorrect, or something has happened. So in that case, again, client will signal the name node. I want to read it. There is some data where there is some problem with the data which is lying on data X. Please get it corrected, and also let me know from where now I can read it. So then name node will return some other node where the data copy is lying, and in that case it can return anything Z or Y, and the client will read it from that corresponding data node. Is it clear, Narsima, now? Okay, Narsima says yes. Okay. So I'll be moving on to the MapReduce part. I'm closing this PPT. I hope everyone is clear with this PPT. If anyone has any questions, just ping me right now. Okay. So guys, I'm bringing everyone on the air except Narsima. I think I can hear everyone. Narsima, you can just check your mic settings. So guys, I have shared some softwares also with you. I hope you have downloaded them.
Hello?
Yeah, Manfa, I can hear you.
Actually, I have few. I need to download few more.
Okay, not a problem. You can download it, but I'll also be explaining you what these are, and then you can download them and install them. And you don't have to download all of them. Some of them are 64-bit, some of them are 32-bit. So based on your bit size of the system, just download the corresponding one. And there are two huge big files called VM or something like that. And you can just download any one of them. Both of them are different versions of the software. So you don't need not to download all of them. And I'll just show you how the system looks like, and just give you the real feel of the system, and then I'll be moving on to the MapReduce part. So what I've shared with you also talk about them, and then we'll be looking into this card. Narasimha Rao has left. Okay, he might be back again in some time. So guys, I'll just give me a minute. Let me open the So these are the software which I've shared. I hope you can see the drive where I've shared it. One is Eclipse. Narasimha, you are back. Just speak up if I can hear you. Looks like there's some problem with the Narasimha's mic. Okay. So guys, I've shared two versions of Eclipse. You can just download a 64-bit because I hope every one of you has 64-bit hardware. And then there's something called putty.exe. Download this file. There are two virtual boxes. You can download. Which is this one? What is the size of this one? How can I check the size? Just a minute. VMbox 4.3.2.12. Just a minute, guys. Just a minute. I'm just pausing the share the screen. Just give me a minute. I'll just get back. I'll just tell you which one will work for you. Okay, so you can download this VirtualBox 4.3.12 and this thing. This is a software which you need to install, and this is the VM which you will be using up. So you have to download both of them, and this is the file sharing FTP software. So just download all of them, and the 64-bit, leave this 32-bit. So other than that, download all the softwares, and I'll explain you I'll just show you how this software looks like. And once every one of you is download them, I'll also tell you how to install them and things like that.
Like I already have Oracle VirtualBox.
Okay, cool. So okay, so so I'm just coming to that point. If you have Oracle VirtualBox or anything like that. So guys, I hope you can see my screen, right? So when you install Oracle VirtualBox, just it's an exe file. Just keep on clicking next. So if you are using this thing, Apple or something, and just download the Oracle VirtualBox from the internet. It might not work on your PC. Just download the correct one for Apple, but this will work on the Windows. I've shared for the Windows, and if you want for the Apple one also, I'll share that. But this might not. I'm not sure whether this will work on Apple or not. So you can download it from the Oracle VirtualBox website. Otherwise, I can share it with you if you are facing problem figuring that out. I hope one of you had the Mac, right? One of you had Mac. Who I don't remember.
Maybe Narasimha.
Okay. Fair enough. So other than that, I think Mansi and Gautam, you had Windows. So okay, Narasimha also don't have Mac. Might be Zubair. So if that does not work on the Mac, do let me know. I'll share another one. But this will definitely work on the Windows. So when you click on exe, it will install it. Just click on next. I hope you know how to install a software on Windows. And then start the Oracle VM VirtualBox. It will be something like this: Oracle VM VirtualBox from a program settings, and something like this will appear on your screen. Do at the back end and after the session, and then we can discuss in the next class if you are able to install or not. If you are facing issues, I'll definitely help you in the next class. You can share your screen. I will help you. Once you install this Oracle VirtualBox, just go to File and click on Import Appliance. If you want to write down these steps, just write down. Just click on Import Appliance, and something like this will come up. Click on this button, browse this file. This is vm.ovf file over here, and click on Next. Don't do anything, and just do next. And something like this will come on your screen. Hortonworks Sandbox 2.0 or 2.1. I'm not sure which is that version. Probably that is 2.0 only. So something like this will come on your screen, and then you have to right click on it and start it. Right now it is started, so it is not showing the start button. Otherwise it would have shown the start button. So it will start something like this. It will pop up a window something like this, and it will start something like this. If you bring a mouse over here, mouse will disappear. So this is the beauty of this screen, and just move away the mouse from here and it will appear. Or if mouse will in this area, it will not be visible to you. This is a text area. It will take 5-10 minutes based on your RAM and other things to start up fully. Try these steps, write down. Try these steps. Wherever you fail, do let me know. I'll help you. So there are two things which you talked till now. You have installed Oracle VirtualBox. You have clicked on File, imported appliance of your and imported this OVF file into this VirtualBox, and this is how. And they have just actually after coming to this machine, Alt tab and everything don't work. So and you have restarted it, and it will start, and it will look something like this. Any questions till now? No. Okay. So guys, what is this? Machine? What is this software which is running on your PC? This is your Hadoop distributed. It's not a distributed file system. It's a single node system. So here there's a name node running on the same machine and a one data node running on the same machine. Name node and data nodes are nothing but the processes which are running on a particular machine. So name node and data node, both the processes are running on the same machine. So in the distributed file system also, you will be running the same commands as you are running over here. There will be no change in the commands which will be triggering over here. That will look similar to you, transparent to you, but this will give you a infrastructure to run your programs and commands locally on your PC. When you will be running them on the distributed file system, that will be pretty similar. There will be no changes in the system. So you will be able to run all the commands, all the programs which you will be able to run on the distributed file system. There's a single node cluster. So I'll show you an example of how the multi-node cluster also looks like, but we cannot install it on your laptops to do the programs. Okay, guys. Any questions? Anything? Okay. Now some of you knew Java also. Do let me know who knows Java. Natsimma has some idea. Mansa also had some idea, and Gautam. I can understand the code.
Yeah.
Okay, so all three of you understand Java a little bit. Okay, that's fair enough. If you understand a little bit, that's fair enough. So when you open this Eclipse standard Win32 64-bit, and before that, please ensure there is something called Java which is installed on your PC. If Java is not installed on your PC, just Google install Java or download Java, and you'll be able to install Java. So before running this Eclipse standard, please ensure that Java is installed on PC. And once you install the Java, download the software, unzip it, it will look something like this. It will look something like this, Eclipse, and inside Eclipse there will be so many files. There's something called eclipse.exe, double click it, it will open something like this. You will not be able to see this code, but it will open a blank window for you, something like this. Okay, and then I'll be sharing this whole code, how to import it in Eclipse, how to run it, then I'll be sharing that thing. Any questions till now with these softwares? Okay. Then there are two more things which I've shared with you. One is called putty.exe. When you double click this putty.exe thing, it will look something like this. It will open a window something like this. It will open a window something like this, and make sure that this window is started fully. Oh, sorry. Make sure this Hot&Works sandbox is started fully, and it has given this screen. You can access this SSH by so and so port and so and so. Make sure this screen has came. After this screen has came, double click this putty.exe and it will look something like this, what I'm showing on your screen. Type in the host name, write down this step, type in the host name 127.0.0.1 and on the port 2222 and click on and just press enter. When you press enter, or you can save it also by any name, you can give a name over there and click on save, so it will be available for your future work. So I've just saved it, and when we open it, there's a black window, black box opens like this for you. Now we are into our cluster. So when this window will pop up for you, it will ask you for the user ID and password. User is Hugh and password is Hadoop. User is all in small Hugh, H-U-E. Hugh, password is Hadoop. I hope everyone is writing these steps. Someone has pinged me, Narasimha, and make changes. Okay. Anything till now which you have not understood? I want you to try these steps at the back end, and then we'll be discussing the problems which you are facing. But everyone, I hope, is writing these steps. Okay. So on this window, it will prompt you for the username and password. Username is HUU in small and password is Hadoop. Everything is small. HADOOP. and then after entering the username and password, you will be on the Hadoop screen. Password, I'm just pinging you on the screen. I'm pinging you on the chat window. You is the user and password it. Everything is small. So this Eclipse will be using to run the Java code writing the MapReduce program. I'll be sharing you all the code which I'll be discussing in the class. I'll be also sharing the PPTs which I'll be covering up in the class, and I'll be creating a shared folder. So the code, as soon as I'll be covering in the class, and the PPTs which as soon as I'll be over with that PPT, I'll be sharing into the same drive. Log on to the same drive and keep on downloading it for you.
Actually,
Yeah.
I'm sorry. For Putty, I have downloaded it already, and I have my own username and password. Do I need to?
Mansa, Putty is nothing. Putty is a client. So Putty helps you to connect
Yeah.
to some of the server. So the username and password which I gave you is the username and password to log into the Hadoop server which you have started right now, the Hadoop machine which you have started right now on Oracle Virtual VM. So Oracle Virtual VM is the virtualization environment which virtualizes your OS into another OS which is running superficially on top of that OS.
Mm-hmm.
Just try out these steps. I'm sure definitely you'll be facing some problems somewhere here or there. I'll help you
No,
out.
actually, I have a virtual machine and then also Putty. So the
Okay.
username and password, I have given it as my
Okay. Fair enough.
own.
Fair enough. Okay. Fair enough. So that's not a problem. You can add the users. I'll tell you, and yeah, definitely you can change the username and password. That's not a problem. Only the thing is the user.
And do we need to check the IP address every time we connect, or is it like
No, you
should
can
I give
save.
the IP?
You can save it like this. What I told you. You can just give the IP address over here and 120. So I have saved it. I have given this IP address. I have given this port. I have given a name to this and clicked on save. So it's available over here. Next time I'm just double clicking this name. And it's loading for me.
Okay, sure.
Um, so this is how your system looks like. So this is a Unix console. If anyone of you is not acquainted with the Unix console, do let me know. But this is a simple Unix console. If I say ls, it will print the folders for me. If I say cd, design DSI design Pathshala, it goes to design Pathshala, and this is the folders and the code line over here. And if I have to look into HDFS Hadoop file system, I'll be triggering some commands. Listen to them carefully. How to look into the Hadoop file system. So to look into the Hadoop file system, I have to trigger commands which are starting with Hadoop. So if I say Hadoop, FS means Hadoop file system commands. So Hadoop fs minus ls is a list command which is similar to Unix command, and say I want to list the folders which are lying on the root of Hadoop file system. So previously when I said ls, that ls was triggered on the Unix file system. Now I'm triggering ls on the Hadoop file system. The Hadoop file system is lying on this Unix environment. So when I say Hadoop fs minus ls slash, that means root, it will give me the folders available in the Hadoop file system on the root. So these are the default folders on the Hadoop file system on the root. Similarly, Hadoop fs minus say minus ls say temp can verify some file. Let's check. Okay, there are a lot of files. Hadoop fs minus cat. If I say cat, I'll be looking into this file, but I'll say tail instead of cat. Oh, okay, so directories. Sorry. So this, so basically, the commands like we do in Unix are available in the Hadoop file system, but you have to prefix them with Hadoop fs. So if you want to look at the list of the files which are available for Hadoop file system command, that is Hadoop fs command, you just type Hadoop and fs on the screen and press enter. So it will give you all the list of commands which are supported by Hadoop fs. append to a file, cat, checksum, chmod, cp, dp, and all those things. I'll just explain you few of the things which are really useful. Other than that, you can just look into their help. There's a lot of command, but I'll just quickly explain you what these commands are doing. So cat is nothing but to print your file on the console. Cp is copying a file, and corresponding to cp there is something called put. So either we can use put or cp, both will do the same thing. And then rm is the deleting the file. rmdir will delete the directory. And there's something called get also. Where's the get gone? Get is to get the file from your Hadoop file system to locally. So let's try this get and put command. So what I'm doing over here is, say I want to copy this file to Hadoop file system. So what I'll say is Hadoop fs minus put this file to /temp. So I'm putting this file into /temp directory in Hadoop file system, LGF file system. I'm giving a command -put. So it's clear, it's trying to put this file. Now if I say Hadoop fs minus ls /tmp, so see this file would be available over there. There's a lot of files. Invert pattern.zar is here. Okay, this is how I can put the file into Hadoop file system. So when I was talking about the client giving a write signal to write the data, this is what is happening at the backend. The name node has given the signal to write it over here. Right now it's a single node cluster, so the replication factor is also 1. But as a multi-node cluster, you as a client, it's transparent to you, and you will be running the commands like this only. And at the backend, everything will be maintained by your job tracker, task tracker, things like that. Anything till now? Yes, no, any questions, anything?
No questions.
Okay. So everyone of have you seen this Hadoop file system? Anything, anyone of you, or everything? It's all new to everyone. I hope it's not new to Mansa. She has tried some experiments. What about Narsima and Zubair? Oh, sorry, Gautam.
Like little bit, not much.
Okay, so at least you knew these commands which I was telling you, or these are all new to you?
Like initial comments were I know like ls and everything. This I don't know.
Okay. I knew few commands. Okay, cool. If you have little bit acquainted with the system, that's great. That will help to understand it easily. So this is how we interact with the Hadoop file system. Then, as I've shared you Hortonworks flavor of the virtual machine, there's something called Hue user. So if you type something called 127.0.0.1:80A00, that is the port on which Hue is listening, and press enter, there will be a screen which will have some form for you. Just fill that form once, that will not appear again and will trouble you again, and click on go to VM, or there will be submit button or something like that at the bottom of that form, and then it will take you to this screen. So I have already filled that form. That's the reason it has not taken me to that screen. But once you fill that form and give all your information, then next time it will not take you that form screen, and will automatically come to this screen. So this
the port 8000 will be same.
Yeah. If you are using the same VM which I have shared with you, this will be all same. If you are using some other flavor of the flavor of Hadoop, then these ports might differ based on the flavor which you are using. But if you are using the VM which I have shared, everything is same.
Okay, but like okay.
Sorry.
No, you can.
And it might ask you for a user. Will it ask for user and password? If it asks for a username and password, just look into the screen view thoroughly. The username and password default will be written on the same screen. Somewhere on the top or bottom, they have written the default one for the U. Just type use that username and password. If it asks for, I'm not sure whether it asks for or not. It's stored on my PC, so it has not asked me for it. But if asked for, just look into the same screen. It's written somewhere on the top and bottom on the same screen, which pops up for the login. And once you log in, something like this appears for you. The default one should be Hugh only, as I recall. But if that does not work, do ping me on the Skype. I'll let you know the correct password. Otherwise, it will be available on the same screen only. So from here also I can browse the Hadoop file system. So if you click on this button called File Browser on left hand side of this screen, this will take you to the Hadoop file system browser. So I can look at the Hadoop file system from the UI also. So if I click on this file browser, Hadoop file system is visible to me. So if you remember this, there is a folder called temp on the root. So I am on root now, and this folder called temp over here, and we copied this some jar. So this is the jar which we have copied. So here from here also we can look into the system. Okay, and there are a few more things over here. We can upload the files from here or from our local Windows machine directly to the SDFS from here, clicking on the upload button. Otherwise, there are other options also, I'll tell you. And I can create a new file directly over here, new file or directory, by clicking this file and directory. So if I say file, if I say file, .text and just submit. So the text is created. I can click on this file, it will open me file, and I can just click edit file. I can enter the data into the file also, and can save it also. So these are some of the UI interfaces which are given on top of Hadoop file system with this Hue browser. Then you can delete the files directly from here. It's a kind of UI interface on your Hadoop file system. You can delete the files from here. You can change the permission. I hope you understand all what are kind of permission available into Unix machine. Same fashion of permissions are there on the SDFS file system also. So read, write, and execute sticky recursive, same as they are there in the Unix. Same are there over here also. If anyone of you don't understand them, do let me know. I hope you all are a little bit aware with the Unix file system. So the same kind of permission level are also available. You can change the permissions by clicking the screen. You can get different permissions to these files. So these permissions are to the SDFS file system. We are not looking into the Unix file system at all. You can copy, rename files over here. There are buttons available over here. So everything what you can do from the console over here by giving Hadoop fs Hadoop fs command. Most of these things, probably all of them, you can achieve it from this UI also. Any doubts? Any question? No. Okay. Bottom of this is no. Okay. Cool. So this is how can browse the file system. Then if you remember, I told you some of the terms in Hadoop file system: pig, hive, woozy, and number of things. So all of them as a process are running over here and on this screen. Will a different yeah. Narasimha, you can use any version of Eclipse. I don't have to worry. I don't not have to worry about that. It's just a beautiful UI and helps you with writing the Java code properly. Otherwise, you could have written in the Notepad also. But the problem with the Notepad is you will not be able to compile them and do all those things. You have to do them manually. That's the reason I've shared the Eclipse with you. Whatever version of Eclipse you have, that's fair enough with me. All you have to do is just write the code over there or change the code which I've shared with you. So you can use any version of Eclipse, no, not to worry about. If it's able to compile and you have Java 1.5 plus version.
And I would like to ask you one more thing. I have virtual machine already, so if I download Hortonworks and then give the username and ID which you have given, will that work for the
So Mansa, I'm not sure. So virtual machine you have downloaded from Cloudera, Huttonworks, from where you have downloaded the virtual machine?
Cloudera?
Cloudera. So Cloudera might have a different username password. So when you will be importing this virtual machine, that will be visible separately on your Oracle VM VirtualBox. And if you will start this machine, in that case the password will be different.
Okay.
Okay. So your Cloudera would also be visible over here like Cloudera. Then if you don't start at Cloudera, you start this one, then it will be visible as this. And guys, one more thing, if you are able to run it and on the run, after running, you are not able to put it from this putty, please stop the machine, click on settings. Click on settings. Some of you might be sitting behind firewalls or somewhere. People sitting in offices always tell me they are not able to do this, do that. And the port block or something like that always happen with them. So click on network. Adapter 1 would be there for you. Don't do anything. Go to adapter 2. These are disabled because right now my VirtualBox is running. This sandbox is running. Otherwise, it will be enabled for you. Choose host only adapter. You can write down if you want. Choose host only adapter. And if you are using Wi-Fi or if you are using cable, just click on cable. If you are not using cable, no need to click on. This is your wish. And click on OK. And then start it. If you are facing network related issues while communicating to that VM. So people sitting behind firewalls and sitting in the company networks a lot many times tell me that they are facing such kind of issues. Okay. Then this is a file browser. Then I was telling you that all these software which I was telling, all these different things which are already running. So the pig is running, Hive is running, Uzi is running. The versions which are running over there in this VirtualBox are all displayed over here. So I hope now you are at least aware there's something like pig, Hive, Uzi, Ambari, HBase. And that's the reason I was just talking about these terms in the first class so that now they do not sound like alien to you. So there are different things over here: Pig UI, Hue UI, HCatalog, Uzi browser, Job browser, all those things. We'll be looking step by step. I'll not confuse you with all of these things on the day one. But I'll tell you one more UI. If you change the port from 8000 to 8080, 8000 to 8080 and press enter, it will open something called Ambari. The password is admin. Sorry, the username and password are admin. I'm just sending you the URL also so that you are aware of Ambari. And the user is admin and password is also admin. This will open the Ambari UI. What is Ambari? Ambari is used to maintain your cluster. But here you can look into the cluster, which processes are running on different data nodes, how many data nodes are available in my system. I can add data nodes directly from here. I can look into the different processes running in the cluster, and I can look into a number of things. So on left hand side, you can see easily the processes which are running. If I click on any process, like say if I click on Hive, it shows me the process is started. I can stop it from here. I can rerun it on the dashboard. I can restart the whole cluster services. So I can restart all the services directly from here. Stop all, start all. So this will ensure that services across all the nodes have been stopped and restarted. So it's a kind of UI which helps you to maintain the cluster. I'll be giving you more details about this also. Although we will not covering the admin part, but I'll give you some other details which are really useful for you as a developer. What you should know. I'll be covering those things, but not going into deep at this part of this session. I want you to understand the system before I can explain you all these things. So you can see SDFS related configurations are here. Yarn, what is Yarn? I'll cover. This is Hadoop version 2. I'll cover that part also. Then the MapReduce and all those things, the configuration related to them, everything is available here. I can start and stop these services. I can look into the hosts which are there. So right now this is a single node VM, so only one data node, and the services which are running on that data node. If there are more than one, then there would have been displayed over here and things like that. So I'll show you one of the real cluster also, and it will be all same. It will be all same. There will be no difference. Only the thing is there will be few node data nodes, but you will be running the commands as you are running on this VM. Cool. Everything fine till now? So, and I hope you have got the meeting invite today for a little bit extended session, and no one has issues with that because in the last class we were facing some network issues, so we were not able to cover a lot of things. So that's the reason I've asked the site to little bit extend the session till for half an hour more. So that's not a problem with everyone. That's not a problem, right?
Yeah. Yeah.
Okay. Okay. So guys, let's take a quick 5 minutes break. So you can also catch a glass of water. I desperately need a glass of water because I've been speaking for last 1 hour. So let's break for 5 minutes. We'll be back in 5 minutes, and then we'll continue the MapReduce part. Is that fine? Okay. So we'll meet in next 5 minutes. I'll be back in 5 minutes. I'm muting the session for timing. Hi everyone, I'm back. Are you there?
There.
Okay.
Hi Raj, I'm there.
Okay. Mansa, you are also there? We'll just wait for a minute for her. So which city you are in right now?
Hello, yes, I'm there.
Oh, you are there. Okay.
Okay.
So just waiting for you only. Okay. So let's look into the MapReduce now. So these are commands to interact with Hadoop file system, which I've just shown you a few minutes back. You can just type Hadoop FS and then Hadoop related file systems. MPDIT to make a directory, ls to list the files, lsr to list them recursively, minus put to put them into Hadoop file system, minus get to get it from the Hadoop file system. So only the thing is, when I'm putting it, I'm giving this local. This is the local thing, and this is the Hadoop related file. This Hadoop file, and when I'm getting it, this is Hadoop file, and this dot is the local directory where I want to put. So this changes. Minus cat is to get the file, minus rm is to remove the file, and things like that. Now here, if we want to interact with Hadoop file system from our Java code, then I'll just quickly tell you how that can be done. However, in a real time, you will not be using the Java code to copy the files or getting the files or interacting with Hadoop file system from the Java world. There's a pretty good UI. There's Unix commands, but just for your knowledge, I'll just tell you how that can be done, and then we'll be moving into MapReduce world. So this is a package which is used whichever Java. I'll be talking a little bit deeper into Java side for next few slides. Just bear with me, and whichever thing you don't understand, do not hesitate. Just ask me. I'll explain you those things. I'm presuming that you have a little bit understanding of Java world, and you understand the little oops concept. I'll not be going deeper into this side, but wherever you are not able to understand it, just ping me. So this is a package which contains all your Hadoop related file system related files which we can use to interact with the Hadoop file system. And when we get the configuration is to get the Hadoop related file system, and then when we say file system dot get, we'll get an instance of Hadoop file system, and we say file system dot get local, we'll get an instance of the local, that is the client where the client is sitting of that Unix box. So this is how I get the references of local and Hadoop file system from the Java program. Let's look into the Java program how that is achieved. So say this is my main method of the class. So what I'm saying is configuration is new configuration, and I'm passing the configuration to file system dot get configuration, and that will return me the HDFS file system object. And if I say get local, it will return me the local file system object. So what I'm doing over here is I am getting the files from local directory for all those files. So I'm getting the files in the local directory. Local dot list status input dir will give me the status of all the files in the directory. And then what I'm doing is I'm creating a new file in S2 SGFS word, sgfs.create. And then I'm looping all the files which are there in my local directory for input files length. So I'm looping it and combining their data into a single file and outputting that into the new file which I've created to SGFS. So if you remember in my first session, I've told you Hadoop is a file system good enough for bigger files rather than small files. And I hope one of you answered that question also. Why? Because name node otherwise will maintain so much better data about files and name node will get full. So it's always a good thing to maintain bigger files rather than maintaining smaller files on your a lot of smaller files on your SGFS file system. So what we are doing in this program, we are getting all the files which are lying in a particular directory. Say my data is lying distributed in 10 different files in my local directory. I'm combining that into a single file and putting it into a Hadoop file system. So I'm just moving the data from local file system to the Hadoop file system, and in between I'm just combining it to a bigger file. So and this is just an example program how to interact with Hadoop file system. Let's try to run it and then show you. Any questions till now? Anything which you are not able to understand? Or anything which you want to understand in this program explicitly? I'm assuming you have a little bit understanding on Java, so you understand what is bytes, what is read buffer, how to initialize an object, and all those things. What is for loop, how and catch and try, and all those things. Okay, nothing from anyone, so I assume that you are getting it. If you are not getting it, do let me know. Okay, so let me share collapse. So this is the program which I was talking about. I'll share you the whole project. When I'll be sharing you the project, what you have to do is just go to when you double click that eclipse.exe file, something like this will open up for you. Go to file, import, and general, existing project into workspace. Next, browse the project which I'll be sharing with you, and press finish, and something like this project will appear on your screen. Okay, and once you import it, I'll be sharing the Java files which we are discussing in the session. I'll not on the first day. I'll not share all the code which we'll be discussing across the session. Otherwise, that will make you confused also, and that will you'll be a little bit scary about everything. So I'll be keep on sharing whatever I am discussing in the class. So I'll be sharing the files which I am discussing today. This is the read program which I was discussing with you. So what we are doing over here is I am getting the the configuration object. I am setting the file system name. So you remember the namespace I've told you in one of the slides where there was 4 computers on the left hand side and 1 node on the right hand side. And I said rather than me remembering where my data is lying, I'll be just giving the namespace / directory, and there's a duty in the system. It will give me that file. So the namespace is the namespace by which the whole system is represented, and I'll be talking with the name node. I'll be giving him namespace / the directory, and name node will return the files in the directory to me. Everyone remembers? Narsimha, you remember? Yeah. Narsimha says yes. Zubair, sorry. Gautam, you remember? Answer says yes. I assume yes for Gautam also. So this is the namespace for this VM which I've shared with you. So that's the reason it's been hardcoded over here. So this is the namespace of this file system which I've shared with you. So wherever you require that, this is the namespace. So I'm setting the configuration that this is my namespace name and getting the file system for that namespace. So, and then I'm just okay, in this program I'm just listing the files in SDFS. I'm not combining them. This program is list files in SDFS. So I'm just listing the files lying in the SDFS. To run this program, what you have to do is go to File. Again, write down these steps if you want to. These are nowhere written in any of the slides. Write down, these are the manual steps. Write down these steps. So to test this program, you cannot test this practically, but just right click and run a Java application. Then you will get an error because this will interact with LGF file system. But just click this run as Java application. Why? I'll just tell you in a minute. And when you click on run as Java application, you will get some errors. Don't worry about them. But why I have ran it? There's a reason behind that. So you will get some errors because it cannot communicate with the Hadoop file system from my Windows machine. So what you have to do now is to take this program to your Hadoop world and run it. Click on File, click on Export, click on File, click on Export, click on Runnable jar, and all this thing you will be inside Java. You will be looking. There will be something called Runnable jar, or you can just type over here RUNN, and this will bring your Runnable jar. Click on Next. Browse the folder where you want to get this jar, and say.
Can you just repeat that once again? How do you do that?
Sure. I'll just repeat it. So that was Mansa, right? So let's say it's Mansa.jar. Mansa. So Mansa, I'm just repeating. Let me finish it. I'll repeat it once again, and so that will do. Okay. So why I have ran it over there? Right click and ran it. The reason is in this drop down. Otherwise, that file does not appear. So in this drop down, now you will be able to see that file name list file.sdfs. The one is because I have ran it many times. So just remember to select it. Browse the directory where you want to put the jar. Give a name to the jar. Right now, I have just given it Mansa, and I have selected radio button called package required library into the generated jar, so that I don't have to give any dependencies while I'm running this jar into our Unix file system, and click finish. It will create me some jar.jar file at that folder. Okay, jar has been exported. It might give you some warnings. Don't worry about them. But if I look into that folder, but if I look into that folder, but if I look into that folder, see this jar has been created. You are able to see my screen, right? Hey guys, you are able to see my screen? You are awake?
Yeah, but then
like I think we are little slow. We can see your mail and stuff there.
Okay, sorry. Let me close this mail stuff. Now can you see my screen? Folder which has the jar which you have created right now?
no.
No?
Mm-hmm.
क्या मांगा है? Now?
Yeah.
Okay. So see, the jar has been created from the Eclipse, and what you have to do is now you have to move this jar to your virtual box. So now I'm using the software, the 4 software which I was discussing with you. that is this WinSCP. So when you double click this WinSCP, it will look something like this. Okay, and you have to click new. When you click new, something like this window will appear for you. Type the host name as 127.0.0.1, port again same 2222, username you, password is Hadoop, and click on save so that you can save it for the future purpose. Give it a particular name. I have given it Hortonworks, and login. So next time you don't have to enter username and password also, and click on login. Now from the left hand side, this is your Windows machine, right hand side is your Unix machine. You can just drag and drop the file. So if I want to drag this file to the Windows machine, all I have to say is I'll have to just select this, and the folder where I have to put it, I just select it and leave it over there, and it will say copy. I'll say copy. Okay. Now I'm repeating the whole process. Write it down. There's still confusion, do let me know. Open Eclipse, file, import the project I'll be sharing with you. Import a simple Java project. So inside general, you will see existing project into workspace. Click on next. Browse the project which I'll be sharing with you, the top folder of that project, and click on finish. Something like this MapReduce project will appear on your screen. That might not contain all of these files. I'll be sharing these files slowly with you, but you will be able to see at least the files which I've discussed in today's session. Open any one of the file, right click it, run it. Why to run it? Because so that file is appear in our Dropbox, which we are just going to look at. And click on file, click on export, click on runnable jar, RUNL, and runnable jar. Click on next. Browse the directory where you want to put your jar. Select the radio button, package required libraries into jar. Click on finish. It will, and before that give the jar name also. And from the drop down, select the class file name which you want to run, and click on finish. And use this WinSCP to transfer the jar from here to there. Mansa clear?
Yeah.
Okay. So this is how I will be compiling our programs and then running them. There are other ways also to compile create jars. I am using Maven. Maven is pretty much easier and is a command line interface to create jars and things like that. But I don't want to get into the complexities of this Java, detailed Java world. That is not intended for this session. So, but this is the way you will be creating it. So the jar which I am creating and jar which you will be creating is all same, but the way we are creating is a little different. So once the jar is created, copied over there, so the jar might already be lying over there. So MapReduce snapshot is the jar name which I have given it, and it's already lying over here. So let's go to that Unix machine. Okay, and ls minus tr. So MapReduce snapshot.jar is already lying over here. So what I have to do to run the jar, what I have to give is write down again these commands: java minus jar and your jar name. And in your case, the jar which you have created was an executable jar where we have explicitly mentioned while creating the jar the main file which need to be run. So next thing which I'm writing, you need not have to write, but I have created this jar by some other method. So I have to give the exact file name which it has to run, because there are other files also lying in this jar. So I have to just tell them which main class to run. But you don't have to do that. Otherwise, these all helps are written in the class files also. So don't worry about them. I have written them as a comment at the below of the file. If you forget that this is written for you, Hadoop jar name. This jar name you have to change, and then the class name. I'll be sharing this jar also with you, so that if you are not able to create it, at least you can run it. So this is the command you have to give, and then the folder which you want to browse. So this let's say browse this folder. Oh, sorry. And a space and the folder name which from where we want to list the file. So let's say we'll look into /temp only. We were looking into that. So tmp. So this jar will trigger. Oh, fail to load the main face class attribute from the snapshot. 1 sec. Now, what is the file name? List file SDFS. List files SDFS. Dot design patch dot Hadoop dot FS what is the problem? This might not have this jar. Let's run the other class. This might not have this class. Let's run the other class. Yeah, just a minute. Yeah. Just a sec. Let me recreate this jar. It was there. Oh, sorry. Oh, sorry. I was giving the. Just a minute. This is the way to run a Java jar. I'm sorry. We are in Hadoop, but sorry. So for Hadoop, you have to give Hadoop jar. Sorry. This is also written over here also in each of the file Hadoop jar. This is how you can run a jars in Java world. So in the morning I was running some Java program. So that was still there in my mind. And then the jar name and the class file which you want to run. So the class which you were running was list files. So we are listing the files in the temporary directory. Guys, you are very much silent. That gives me an impression either you are not able to get it or everything is very, very clear to you. So see, we have looked into, so that is given the files in the temp directory. So what we did in this class is, in this class we have just get the file system object and we set list status that will give the files in the directory, and we are just printing them one by one. And we have created a jar. We have given a command Hadoop jar name and file name. This class name you need not have to give. If you are creating the jar which I've explained it to you. If you are using the jar which I'm sharing with you, you have to give this class name. And the reason is I am not creating a runnable jar. You are creating a runnable jar by giving the main class file while creating the jar. Is it clear, or am I going above your heads?
No, it's clear. Like we can't write Java code, but this one we can do it.
Sure. So I'll be sharing all the Java code also. I'll be sharing the jar also with you. And try to run it. This is how you interact with the HDFS file system. So that will give you at least an idea of how you, if you in the future you have to run some Java code to interact with the file system. You are aware of this. So so that because later on when you have to run it, no one will be there to teach you. So I don't want to skip these things. And that was Narasimha, right? Mansa and Gautam? Clear?
Yeah, just now I only spoke to it. So, yeah.
Oh, okay. So Narasimha and Mansa, it's clear?
Yeah, so far it's okay. I think we should try it and it will be clear.
Yes, definitely. So that's in the next session when you are all done with your software installation and things like that, then I'll tell you to write it and run it over there. So that, and in the meantime, over the weekend, just try to install everything and try to run the jar which I'm sharing you, and then you can definitely write. I'll give you in class assignment to write the.
You want us to just run the jar file, right? Nothing to be edited in the code.
You can try to change the code. Always try to change it. Why you don't want to change the code? Try to do things whatever you think you should do. You might try reading, writing. You might try getting a list of files, and you can try a number of things. This is how you interact with the file system. Just try different things. But in this class, I'm not giving you any assignment. Once all your desktop and software are set it up, I'll give you the assignments also, which we'll be discussing in the class. But this is not that much useful. The more useful thing is MapReduce code. So there I'll be definitely giving the assignment, and I'll be explicitly asking you to write the programs. But here it's all your wish. So this is how we integrate the file system. Here I was listing. Here I'm reading a particular file. So I've got the information of the file. I'm creating that file object over here. HDFS file, which I will be passing as an argument to this program, and I'm just printing that file, looping to the file, and printing that file. So if I run read HDFS, so guys, so here I'm just changing the file name for me and running it, but in your case you have to recreate the jar because you are creating a runnable jar, and you will not be giving this in between parameter to run your jar because you are creating a runnable jar. And just give that, the other things, do remember, because I'm using a jar created by Maven, which is not a runnable jar, so I'm giving explicitly the file which need to be run. If you are using the jar file which is lying in the code which I am sharing you, if you're directly using the jar file by this name, then you have to give this whole command. So this is, I can read a file that lying in the GFS file system. So here I'm reading it, and in this program I am merging the files which I've explained to you on the PPT. So I'm reading the two file systems. One is the local file system, one is the LGFS file system. From the LGFS file system, the input directory is the first parameter which I am getting it. args0 is the first parameter, args1 is the second parameter. I am getting them and creating an object and just reading it. So this is the way you can integrate the Hadoop file system. You don't have to worry about the Java code much. This code you will not be using anytime in the future, but you definitely, when we're talking about the MapReduce code, I want you to understand each and every line of that so that you are aware of how the system works, and then you can very easily write big and high codes. Fair enough, you can try these things. I'll share with you. If you face any problem, do let me know. If you don't understand any part of the code, do let me know. You can just drop me an email also, or you can ping me on Skype, or you can discuss in the next class. Shall I move ahead?
Yeah.
Sure.
Okay.
Will you share the first PPT today?
Yeah, I'll share you. I'll be sharing the PPT.
Okay.
So now you understand the system. System looks something like this. There are nodes, there are processes running on nodes, and those processes are called map and reduce, and they do all the processing. Okay, so what is the map and reduce phase? There's something called, on this slide, do not worry about in detail. I'll slowly giving you the details. If I just give everything on the first slide, then you will all be confused. I'll be slowly giving you the details. Do not get indulged in the complexity of the slide. So there are three things which are really running in the system. One is called mapper, one is called reducer, and one is called in between phase called sort and shuffle. These are three things which really run in a MapReduce program. So mapper program will read the data from your HDFS file system. So here it's reading the blocks. The blue ones are the blocks. So it's reading those blocks and doing the processes which is required to be done on that block and sending that data to the sort and shuffle phase. Sort and shuffle phase is basically sorting and shuffling the data. What it is doing, I'll just show you in detail. And sending it to the reducer, where reducer is running, and then reducer is processing that data and producing the output into the local file system on the LGFS file system. Any doubt on what I said? Don't worry about the complexity of this slide. There are three things running: mapper, reducer, and sort and shuffle. Mapper reads the data. Mapper. There's an echo. Let's just a minute. Let me mute everyone. There's something. Okay, so mapper reads the data from a file system, does the mapping. What is mapping? I'll just talk you. Process the data, send it to sort and shuffle phase. Sort and shuffle basically sorts the data which is coming out of the mapper, shuffle it, and send it to the corresponding reducers. Reducer will reduce, do their logic. What is reduce logic? I'll just talk you, and will produce the output to the LCFS file system. If these three terms are there somewhere in your mind, mapper, reducer, and short and shuffle, that's fair enough for the slide. Don't worry about the other complexity of the slide. Okay, I'm assuming this is clear to you. If not, just ping me on the chat window. So said this is the data which is lying in my system, and this red, green, blue kind of boxes is the real data, where red box represent the red data, blue box represent the blue data, and the green box represent the green data. And as a MapReduce program, as a Hadoop program which I have to run, I want to find out the counts of red block in my system, I want to find the count of blue block in my system, and I want to count the green blocks in my system. So I have to write a MapReduce program or a Hadoop ZAR files which I've shown you in the previous screens. So I have to write a program or logic which will do all this calculation, which will go to all the nodes, will find out how many red blocks are available, how many green blocks are available, and how many yellow blocks are blue blocks are available too. So the map and reduce program runs in two stages, now 3 stages. Now you're clear about that part: mapper, shuffle, sort and shuffle, and reduce part. So what will happen in the mapper phase is, mapper phase will read the data from Hadoop file system. So map will keep on reading one by one data and will produce something like key and value pair. Everyone understand what is key and value pair? That is very, very, very critical to understand map and reduce. If any one of you don't understand what is key value pair or hash map kind of things, do ping me right away. Otherwise, it will not make for you any sense to understand MapReduce code. All of the MapReduce logic and flow works on key value pair, hash map kind of thing. If any of you don't understand what is key value pair or hash map kind of thing or hashing, do ping me right away. Guys, ping me yes, I understand. No, I don't understand, please. Narasimha says yes, explain key value pair and hashing. Zubair Mansa, you understand it or not? Answer says we do. And Nasima, oh sorry, Gautam, can you repeat once? So Gautam, looks like you are not listening to me. So Gautam, I was saying, if you don't understand key value pair or hashing or hash map functions, so then MapReduce will not make sense to you unless you don't understand these 3 terms by deep heart. So do you understand that part? Okay, Mansa says, but it will be good if you can explain once again. Sure, Mansa, I'll just explain in a minute. Gautam says no. So by now I understand you understand, and you say no need to understand, no need to explain, or should I say you don't understand? Okay, anyway, I am going to explain it. Okay, so what is key value pair and what is your hashing and things like that? Just. You can see my Excel sheet. If not, just ping me. Key and value pair. So what happens is anything, any of the data can be easily represented in a key and value pair. Say I have a data in my let's take an example of our data only, where we were discussing more the orders. So order data would be something like this: order ID or order date, customer ID. The customer is really given this order, order amount and parcel ID, the parcel by which this order is shipped, and commodity ID, that is the commodity for which this order is given. Okay, something like this order data will look like, and it will go something like this. So these are the order IDs, the date on which order was really given, the customer who has really placed this order. So say customer ID this, customer ID this, and customer ID this, order amount, parcel by which this order has been shipped, parcel IDs, commodity which is really shipped into this order. So there will be a separate commodity table which will be talking about what this commodity is. So any of the data would either look something like this, or data could be something like this. Say, hi guys, this is Hadoop class. So this is structure and unstructured. There is a difference between structured and unstructured data. Okay, but any of the data can be easily represented in key and value pair. So if I am talking about the structured data, the key of this data is order ID, because I am talking about the orders. So in the mapper phase, I'll be creating a key, and that will be order ID for this data, and the value will be your data. So value will be this whole. Okay, so this will be all your value. Okay. So this is your key and this is your value. And this is your key. So there will be, so these are the keys which will be created by your mapper, which you will be writing definitely, and this will be your value. It depends on you what you want to keep in the value. Either you want to keep the whole data or the data which you just want, or things like that. It will depend on you. But this is how your value would look something like, and key and value will look something like in your structured data. And the blue ones are the keys. So this is how a key and value pair works in the system. So when I'm saying I'll create a key and value pair, so I'll give some unique key to that data which I am going to process, and that key would be unique for my processing logic, and the value would be the real data or the part of the data if I just want to process a part of the data. So this is how it will look in the structured data. But when I'm processing some unstructured data or doing something like this, then I might be giving different keys. So say I want to find the number of words in this text, and this is my data. Then my key might be the word. So my key might be high, and my value might be again high or something. I'll just explain you a little bit what you will choose a value. But this is how a key value pair works. And then hashing is nothing but is a kind of hashed value or a particular unique value which could be derived out of your key. So if I hash my key, so say in this order my keys are say 123 to 34, or let it them same only. I'll just create a little bit complex. 123, 456, and 654. So these are the three different orders. So, and say my hashing logic says my hash value would be sum of just the digits in the key. So the hash value of this would be 3 plus 2 plus 1 is equals to 3 plus 2 plus 1 is equals to 4 plus 5 plus 6 is equals to 6 plus 5 plus 4. So these are the hash values. So these are the hash values of this thing. So hashing logic will depend, and this is automatically implemented by system. You don't have to worry about this. But so hashing logic would be something like that it will equally able to distribute your keys across the different hash And what this hash used for? This hash is used for to bucket your data. So when I say bucket my data, what does that mean? So hash function will create the kind of hash values which can be associated to the buckets in the system. So there will be a particular bucket which will be handling only the hashed values from 1 to 100, not 1 to 100, say 1 to 5. Oops. 1 to 5, 6 to 10, 10 to 15, 15 to 20. So these keys are candidate of these buckets. These two keys have value 15. So these two are candidate of this bucket, the blue one. These are candidate of blue bucket. And 6 is a candidate over here. So this is a candidate of the yellow bucket. So this is how the hashing helps me in bucketing my data. Any doubts? What is key value pair? What is hashing? What is hash function? How that is used, I'll just explain in the MapReduce phase. Gautam says no. Mansa says bucketing. Okay, Mansa. Nasima? Nasima says no. Okay. So Mansa, bucketing is a process used to segregate your data into different buckets. By bucket, I mean to say, collection or something. You have to segregate the things. If you play cards, and if you just want to check all the 52 cards are there, what you will quickly do is you will filter out the spades cards separately, hearts cards separately, and so on. So you are bucketing your data based on the card colors. So you are creating 4 buckets for each color and putting the cards into that bucket, and this is how. And then you will quickly check whether there are 13 cards for each bucket, and all the cards are 52 cards are there. So bucketing is just a hash logic. We are putting the hash logic on our key, and in the cards example, my key was my color of the card. That could be either hard, spade, or whatsoever. And I'm trying to segregate my data across 4 buckets. So my hard cards will go to hard, my spades card will go to spades, and so on. So all the 13 cards, all these buckets result 13 cards. This is I have segregated my data equally across the buckets. So my hash function over there was the card color. Okay. So by the card example, you are able to get it easily. Guys, just give me a sec. Let me go back to the PPT. Okay, so hope you can see my MapReduce PPT. And now what I'm doing is I'm scaling. What I have to do is I have to find the count of colors which are lying in my Hadoop distributed file system, and the files are distributed across the nodes. And right now, just assume that I'm not looking into repetition factor and all those things, and the data which I'm looking is need to be processed. So this is the data which is distributed across the nodes, and to find the counts of the colors. So while reading the data, so as a code, I have to write mapper function and reducer function. I don't have to write sort and shuffle function. That is automatically done internally for you. That is transparent to you. Don't have to worry about that. That is automatically taken care by the Hadoop MapReduce framework. So in the mapper phase, what I'll do is in my mapper function, I'll create a logic something like this. When I'll read the data, I'll create the color as a key and value as 1, because I have to count the different colors available in my cluster. So I'll produce something like this: key and value pair, comma is the separator of key and value. Anything left is the key and anything right is the value, is the general notation. So it's blue is the key and 1 is the count of that box. So I'll keep on reading these boxes, and I'll keep on producing these kind of key value pair from the mapper phase. Then this key value pair from the mapper would be transferred to your sort and shuffle phase. So what is the sort and shuffling is doing is trying to find out the hash value of the key, and it will assign those keys to to the corresponding bucket. And the what are buckets over here? The reducers, the yellow color boxes which you can see on the right hand side of the screen. So the here, let's say the hashing function is just the color only. So the blue color will go to the blue bucket, red will go to the red bucket, and the green will go to the green bucket. So reducers are correspondingly colored over here. So this short and shuffle function, which is transparent to you, you don't have to write any code for this. Short and shuffle function will automatically do all the distribution for you. That is bucketing of your data to you. So the keys which have blue color will definitely go to the blue reducer. Red will definitely go to the red reducer, and green will definitely go to the green reducer. That is all taken care by the in between short and shuffle phase. So from the mapper phase, I am just producing the key and value pair, where I am creating the key as a color and the value as the 1, because I want to count the number of colors. The value might have been deferred based on the logic which I want to implement. Here in this logic, I'm doing just the count of the color. So it will keep on producing this kind of boxes, and this kind of boxes will then be passed to short and shuffle phase. Short and shuffle phase, from each mapper will give the keys to the corresponding reducer based on the hash value of the key. And hash value is nothing but the color in this case. So you can see the blue are always going to the blue, red are always going to the red, irrespective of from which mapper it is coming. And in the reducer phase, I'll get something like this: the key and the list of values. So this list of values is also automatically created in the short and shuffle phase. In the reducer side, I'm just getting the keys and the list of values. So in the reducer, what I'll do is I'll just count the values inside the list of values, and will produce the output as blue and the count. So say the count is produced as 100. So this is how I did whole counting of the different colors available in my cluster, and this is how a simple MapReduce algorithm works. Is this clear for you? This is very, very, very important for all of this course. I'll be giving you different flavors also to make it more understand, so that it sits in your head. But are there any doubts in this? I'll give you a few more examples how this works to you in next few slides. But is this clear to you? Sumansa says, yeah. Narsimha, you said at 850. Okay, yes. And Gautam also says, yep. Okay. So this is how your map and reduce function works. And the output file would be created, and as you can see my screen, right? And the output file is created, and that will contain only the counts. So my big data, my GBs of data has been processed beautifully by map and reduce algorithm, and the output is just few MBs file which will just contain the counts of the colors. So this is how the whole processing in Hadoop cluster happens. So this is how it will happen. Look into the screen. It is automatically flowing. This is how it will happen on the mapper side. This is how the hashing internally works. All the colors are equally distributed to the corresponding color bucket, where the hashing logic was used as the color. So this will keep on happening as soon as the map is processing the data. It is passing it to the short and shuffle phase. Short and shuffle phase is doing its work and passing it to the corresponding reducer. So this is the continuous. This is how it happens continuously in the system, and keep on happening till your MapReduce program is running. So till all your data is read, this will keep on happening. Making sense? Any questions? So Mansa, would you like to repeat what I have explained till now? This is very, very important. Okay. So this is all clear now. Task tracker retrieves the job and runs. How the whole running is happening. Your job tracker has created those MapReduce programs. Send it to the task trackers. Task trackers are now this mapper is run by some task tracker, and where this data is lying, and the task tracker is producing the counts, and then those counts are just for sent to the corresponding different task tracker, which is running the reducer and would doing the count. Now is that part clear? Job tracker, task tracker, how that is coming in picture and running the whole MapReduce program? Yes. Okay. So now you all are MapReduce experts. So I've just explained it to you how the key value pair is created, that you have to write. Mapper consumes key and value pair, produces key and value pair. We have just seen it. Mapper consumed how it consumes a key value pair. Just wait a minute. I'll explain you. It produces key value pair. It has produced the key value pair of blue color and one as a value. Reducer consumes the key and list of values. So reducer in the previous example has consumed the key as a blue color and the values as list of 1 and produces the output of key and value pair. So there it has produced the output as key as blue and output as 100 as the value. So this is how your mapper and reducer function works. They both inputs key and value pair, outputs key and value pair, and everything works on the whole algorithm and key and value function only. And any of the data can be processed with the help of key and value functions. And short and shuffle phase is again the done, and it takes the key and produces a list of values, which is passed to the reducer phase. So in this phase, what I'm doing is what I'm doing here is what you have to do is we have to just sort the blue colors and then ignore everything else. So mapper will again produce key and value pairs, key as the color and value as the one. And in this case, as we don't have to do anything or anything for the reducer side, we don't have to reduce anything. So in this program, there will be only mapper which will be running, and if the key is blue, it will produce the output as key value pair for it. Otherwise, it will not produce anything. It will just digest that other color for it, or it will ignore that other color. It will not produce it. So there would be some peculiar scenarios where you don't have to write the reducer, but 99.9999% of the cases you will be writing the reducer phase also. But this is a peculiar example which I am showing you where you might not have to write the reduce phase. The mapper phase output is sufficient enough for you to do the thing. So here we are just doing a filtering kind of thing. So looking at the key and just eating it or producing it based on the color. So this is a particular example which I highlighted on this screen. Any questions? Anything? Okay, let's proceed further. So this is all I just covered in the previous slides. How this is happening at the backend. Reducer in the previous example. You've all seen all these things. Let's look into a little bit of detail. Say I have to the next example which I was showing you. How that will happen for unstructured data. So say over here I have to do the word count, the hello world program of MapReduce word. So what I'll do is I'll produce the key as the word and value as the count. So this is how something let's go through the niche. So the key would be produced as the word and the value would be the count of that word. Something like this key and value pair could be produced by the MapReduce program, and that could produce the output as the word count, which word is repeated how many times in my whole file, and file could be distributed in the blocks across the whole cluster. Okay, so what I'm doing is, so this is a file which is distributed across two nodes, and the file contains the words like apple, mango, oranges, and so on. And I have to do the word count. So in the mapper phase, mapper will read the line by line. The data is by default read line by line from the input file. So one at a time, mapper will read the whole line. So it will consume apple, orange, mango, and there will be a default key which will be assigned to this line. And this key, if we are reading unstructured data, text related data, the key is automatically produced from the Hadoop framework, which is nothing but the byte offset of these characters. What is byte offset? Is nothing but I am just counting the ASCII values or something like that from the whole data, and that is a unique key for the whole data. So basically, that byte offset is nothing, but if the whole data is same for some other line, that key might be same. But that will different, and that will go to the mapper phase. So one by one line will be read by a mapper. Mapper will get the key, and key would be some byte offset, which will be ignoring our map function. And what will be consuming is just the value. So mapper gets key and value pair, produces key and value pair. So here the key is something as a byte offset value of this whole apple, orange, mango, and the value is apple, orange, mango. So we are processing now this value in the mapper phase. So in the mapper phase, I am just grouping them by the fruit names and producing the value as the count of these fruit names in that value. So in the first value, apple, orange, and mango, the first line of the first file, and all these three words are there, and the count is 1. So mapper will produce 3 key value pair. The first pair is apple 1, second pair is apple, orange 1, and third pair is mango 1, and so on. And sort and shuffle phase will try to sort all the data and will try to bucket the data based on the hash value of the key. So apple will definitely have all the apples will definitely have the same hash value. So they will be sorted on top, and the sorting is done so that the keys are properly bucketed. Hash values of the keys are properly bucketed, and a particular bucket goes to the particular reducer. So number of reducer could be different, and the reducer side, the key would be apple and 1111, and reducer will just count the values, sum the values, and produce the output. So this is how the unstructured data will be processed by our MapReduce word. Any doubts, any question before I show you the MapReduce code for this whole program? Okay. 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 Everyone says no, no, no. Okay. Okay. Fair enough. So I have a question for you before I go ahead. Say over here in this line, okay, this is the line. This is the line. This is the line. Here I am counting and producing the output is apple 1, plum 1. Should I produce apple 1, 1, apple 1, 1, and plum 1, plum, 1, or apple, 2 and plum, 1? Anyone want to answer?
Yep. Can you repeat the question once again?
Okay. In the line which I've highlighted right now, I'll just put you on mute. So in the line which I've highlighted just now, that is encircled on the screen, the line is apple, apple, plum. So mapper will get that line, will produce the key value pair. Now in this example, it's producing key value pair as apple, 1, and plum. Should it have produced it like this, or should it has produced it like apple, 2 and plum, 1? Anyone want to answer? No answers. Okay. Mm-hmm. I got a chat. Narsimha says Apple 2 Plum 1. Uh, there are two ways to write this program. Either we can produce Apple 1 and Apple comma 1 and Apple comma 1, and the reducer logic could be written in all reducer. But we can write some of the reducer logic in Mapper also, so that will just help us in saving the data which is floated over the network. So here two keys are flowing over the network, Apple 1 comma Apple 1 and Apple 1 comma Apple 1. But this could have been reduced if we would have produced Apple comma 2. So, but both of them will give the equal output because on the reducer phase that is being combined with the help of short and shuffle phase in between. So both of them will give the same output. But if I would have combined it on the mapper phase only, that would have saved some of the network data transfer. Rather than transferring two key value pair, I would have saved and transferred only one key value pair. So this is how the saving could have been done. And same thing happening on the shuffle side also. Shuffle, rather than producing n keys and n values, it combines all the keys, same keys into the same and produce list of values. So it at least saves some of the network bandwidth by not producing n keys and n values. It just produces one key and n values. So this is again how some of the network bandwidth is saved. The data transfer is saved across the network in the short and shuffle phase. Okay, so there are particular classes and all those things. We are doing all this work for you. Both of these are correct thing. I'll show you both the examples in some time. The next example where I am producing the Apple comma 2 might not be covered in today's session. That there's slide on that, but little later on. But the first thing we'll just share. I'll share the code. So this is just what we have seen. Mapper reducer launching the program. So this is how your MapReduce code will look for this. Well, if you don't understand Java or you don't want to write the Java code, you want to do all your processing in the pig and hive, but still try to understand this part. This will really help you in understanding all the pig and hive concepts also. You can easily do the optimization on the pig and hive side by if you understand these programs and MapReduce concepts. I don't want you to be an expert in writing the Java code. If you can run one Java MapReduce program in our whole session, that's fair enough for me. Because most of the time you'll be writing this hive and pig codes to process the data. But if you understand how the concept, the logic which is happening at the back end, that will really help you to optimize your pig and hive code. That will really help you to understand pig and hive very easily. That will help you to configure your pig and hive codes very easily. That will help you to do a number of things very easily. So understand the whole concept. Do not try to mug it up, or do not try to just rectification. Try to understand the concept, and if you are able to understand the thing, it will be very easy for you. So as I told you, mapper function. So there are two things over there, mapper and reducer. So this is a mapper from mapper code which I've highlighted right now on the screen. I'll be sharing all this code for you, and I will liking you to write at least one MapReduce program so that you are aware of how to write that if you need it sometime in your future, in your interviews and all those things. And I don't want you to be very great into MapReduce program, but I really want you to be expert in pig and hive. That you will be really using in your company or projects. But I can't make you skip the MapReduce part also. Okay, so this is my mapper class. To make it a mapper, it had to extend your mapper and these are generics. And in your mapper class, there is a function called map. which will take your key and value pair, and it will output the key and value pair with help of context. I'm not taking into the complexity of context right now on this first slide only. I'll tell you slowly and slowly. So here what I'm doing is I'm tokenizing. String tokenizer is nothing but it's splitting the line based on spaces. So if in this example I've got this line apple space orange space mango, so this split tokenizer will tokenize into three strings, apple and orange, and these will be passed, and what I'm producing over here is the word that is apple comma 1, and for the next one orange comma 1 and plum comma 1. So this is how it is producing it. So context.write is nothing but is writing the output of the mapper to the context which has been passed to your short and shuffle phase. Short and shuffle phase will do his magic internally for us. We don't have to worry. Now we have to write just the reducer code. In the reducer code, I am definitely sure that all the apple, if are coming to this reducer, definitely all the apple will come to this reducer. And their key would be apple and the values would be 1, 1, 1. So iterable values. So over here what I'm doing is I am summing all the values. The value sum is an integer. I am value.get and I'm adding to the sum. At the end, I'm producing the key, that is the apple, and I'm summed all the verbs and producing the output. So apple comma 10 will be produced out of this reducer. And if there are more keys coming to the same reducer, they could also come, because it's not always the case that as the number of the keys are there, as the number of reducer would be there. In a practical scenario, there will be 1 or 2 or 3 reducer will be running. However, there will be hundreds and thousands of keys in your program. So our reducer will be processing more than one key. So all of those keys will be coming to the reducer. But if key X is coming to the reducer, all the values of X will definitely come to the same reducer by the logic of bucketing and sorting and shuffle in between. So here for each key this reducer function will be called, and I'm summing all those values of that key and producing the output. So this is how your mapper and reducer looks like. And there's a main class in your whole MapReduce program. This main class is, guys, I'm going little bit fast. Do ping me wherever you think I'm going fast. Do ping me if I'm going slow. Do let me know if you don't understand. Silence really makes me, scary. I look like I'm just talking to myself, and I'm not sure whether you are getting it or not. So are you getting it? Am I going fast? Am I going slow? Do you want to change my face? Do you want to change anything which I'm talking? Do you want to change the way I'm talking? Anything? I'm giving you one by one. Gautam says getting it. Sima says getting it. Mansa also says yes. Okay. Okay, so guys, wherever you feel I'm going a little bit faster, you want me to go slow, do let me know. I'll go slow. I'll explain line by line. If you want me to explain anything on the slide, if I'm skipping that part, I'm assuming if you're not asking me anything, I'm assuming that you're getting that part. I'm asking that part. Wherever you think need to be explained, do let me know. I can go as deeper as you want. So there's something called main program. Main program is the program which is triggered in the Java program. So in the main program, I'm creating the job. Now you understand that thing, job complexity, what we have created over there. So here I am configuring the job. I am setting the mapper class in my job. Mapper.class, I am setting the reducer class in my job. And I'm setting few more things in my job. Don't worry about that. And what I'm saying is job.run. So this is the line which I have triggered in the previous PPTs. If you remember, job.submit. So this is what job.submit in the previous PPTs, and that is really sending the job to your come on guys, to your where this job is being submitted. I want an answer from everyone. When I say job.submit, where is this job going? Narasimha says SDFS. Mansa and Gautam. When doing job.submit, job client.run, that is really submitting a job, where it is going. Guys, can you hear me? Hello? Guys, can you hear me? Hi, Sai. Sorry? I went offline. Just a minute. Let me check. Just a second. Yeah, just a sec. No, just a sec. Just a minute. Hey guys, am I audible?
Yeah.
It looks like I think I pressed some wrong button or something. I just by mistake I just pressed disconnect or sorry. So I was asking that where this job.submit will submit the job. where that will go. And you can also share my see my screen, right? Just a minute, I'm sharing it, and you can also see my screen, right? I think I have by mistakenly pressed some disconnect or something. So where that submit will go? I want an answer from everyone. When I'm doing this job.run that is really submitting, where that goes? Narasimha said yes, DFS. I would need an answer from other two of you.
Like,
oh, sorry, Gautam was speaking something. I'll just unmute you. Yeah, Gautam.
Same where the files are there, so that the map reducing can be applied.
When I say job.submit, but from a client, I'm doing job.submit. Where that is really going? Job is sent to your job tracker. So this is a logic which I have to run that will go to your, although I'll put this program, this hard file in SDFS Word to run it, but when I say trigger this logic which is written in these files which are lying in this SDFS system, where that trigger command will go, that will go to your Narasimha, that will go to your, I'm unmuting you, Narasimha, that will go to your job tracker. Perfectly fine. So now then job tracker will send this task, all these tasks to your task trackers, and task tracker will be running your individual programs locally. So here these are the tasks, these programs are ran locally on these nodes by the task tracker. And same way, reducer is again a program which will be triggered from a job tracker and will be running individually on the nodes from your task trackers. Now this whole flow which I explained previously is clear how that is used in MapReduce program and how everything works in this SDFS world?
Yes.
Okay, cool. So let's look into this MapReduce program, and then we'll look into detail about MapReduce things and things like that, file formats and all those things. I'm a little more technical in the next class, but in today's class, let's look into this. Let's look into this MapReduce program, real MapReduce program. So see, this is a mapper program where what I'm doing is I'm getting, so this key and value pair is automatically passed to me by the Hadoop logic, and at the back end it is reading line by line and passing me, creating the key that is the byte offset value of the text file and value as the whole line, and it's passing it to the mapper and to this function map function, and I'm getting those key value pairs. So I'm getting in the key, I'm getting the byte offset value, and in the value I'm getting apple space pulp. So I'm getting those key value pair over here, and that is used, and that this value I'm using to create the output from the class. So what is the output I'm going to produce from this class? So Gautam, what is the output I'm going to produce from this class, mapper class?
Like single line converted into pieces.
Yes, and those pieces would be just an example. Any example? Yeah. So like if line, apple, yeah, if line is if line is apple space orange space pulp, what will be produced?
Apple 1, orange 1, pulp
yeah,
1.
Perfectly fine. Yes. So this line is producing nothing but word is the key. Now it's creating the word as a key, that is the apple as a key, and 1 is nothing, that's just a numeric one, which I created over int writable one. So this is one. So it's producing apple comma one, pulp comma one, orange comma one, and mapper is producing key and value pair. So here I have changed the key which is really passed to this mapper class. I've changed the key. The MapReduce framework has given me the key as some byte offset value of that line, and the value is apple space apple orange space pulp. But I've produced 3 key and value pairs of that value. And my key and value pairs are produced from this mapper function. So for each line or each of your line, this map function would be called. And same way, let's look into the reducer. Let's look into the reducer function. And reducer, now reducer will get, so Narasimha, what reducer will get? Looks like Narasimha is away. So Mansa, what reducer will get? Okay, Narasimha just pointed. Reducer will get the sorted and the shuffled data. Perfectly fine. So just give me an example how the data would look like in our example. No, it's not apple comma 1. It will be apple comma 1 list of ones. That is one something like this. Apple comma list of 1. That is all done in between for your shuffle from your shuffle phase. So what I'll get is key as an apple and iterable values. That is all the values which are produced for that key from different mappers. So here I am looping that and summing it and printing the sum. And all of this is triggered from your word count. That is your real job. So here what I am doing is I am creating a job conf that is job configuration that is used as a configuration to run this job, and we are setting up different things in that, and we are triggering it for job to run. So whatsoever MapReduce program you are writing, these 3 classes you will be definitely writing, and this code you will be definitely using. You will be just changing few things here and there in this program, and you will be just changing this mapper function, logic functions, these lines. Other than that, whole of a MapReduce program, what I've written, you will be just copy pasting each and every time. You will never be writing a new code. I myself have never written new code. I'll just copy paste everything every time but I just change these 4-5 lines in the mapper class, these 4-5 lines in the reducer class based on the mapper and reducer logic which I want to run. Rest all things remain same. And if I'm changing the class names or all those things, I'll just change them over there. So here I pass the mapper class and reducer class to this job. I just tell my job configuration, this is my mapper class, this is my reducer class. What are these? Don't worry, we'll talk in a little bit detail in our next session. And I'm just submitting it. Job.wait for completion true is another way to run that, trigger that job. So I'll be creating a jar for this program. So, and how to run that? Hadoop jar name and class file name and 2 parameters. Each of a MapReduce program will always take 2 parameters. Remember, you cannot, minimum 2 parameters are required. One is your input path from where it will read the data. One is your output path where it will produce the data. These 2 parameters are always required and you have to always consume them. And here I am setting these. So args1 I am getting it. I am setting it add input path, and args1 I am setting it as our output path. So these 2 paths are set in the job conf as input and output paths. Okay, so these 2 things are always required by any MapReduce program. It has to understand from where it has to read the data, because our MapReduce program will always be reading some data and processing and producing some output which will return to some particular directory. So args1 and args2, which I have mentioned in this program, is always mandatory for MapReduce program. That is the input and output directory. So guys, we'll be creating a jar of this MapReduce program and you will be running it in the same fashion. You will be creating a jar as I explained it to you. If you are creating in that fashion, this command might not exactly work for you. You don't have to give this class name because the class is a runnable class, and you have to just give this user hue input and user hue output. That is the input and output directly, and you can run this MapReduce code. So I'll quickly run this MapReduce code and then we'll look at it in detail in our next class. And by the time you please set up your environment, you face any issues, do let me know in the next class. I'll help you with that, and then I'll give you some coding exercise to run to create a MapReduce program, and I will also look into the deeper details about MapReduce algorithms. Sure, fair enough. Anything? So I've already created the jar. Everything is in the same jar for me. I'll just try to run it. So let's we can. I'll just check whether the input and output path exist or not. All of you can see a black screen, right? So here is my MapReduce jar. Now what is the command I have to print? Print to run any jar in Hadoop word. What is the command, guys? Get is to get the file. Run the jar.
Yeah.
Hadoop jar file name. The jar file name for me is this. Then I have to explicitly give the class name because I've created this class file a little bit different. So I'll just copy the class file name. And I have given the input and output location also. So first one is the input and second one is the output. So let's see if this program runs. If the output location is already there, it will throw an error. So always take care that output folder does not exist. It will create an output folder for you. It's running the program. So by that time, let's look what's there in this input folder and what would be the output we are expecting. So I'll go to the browser in the meantime, and let's see over there how this what's there in this. Every one of you can see my browser or not?
No, we can't see anything.
Okay, now can you see my browser?
No. Yeah.
Okay, so let's see what's lying in that input and output folder. What I've given to my program. So here I can just directly give the this thing, the folder which I want to access. Oh shit, man! Oh, I have to stop the program. There's a hell lot of things. Just a minute. Let me stop this program. There's a lot of things lying in the input directory. It will run for ages on the small machine. So let's give some particular file to this. Let's give this file. What is this file? No, this file does not contain any words. I want some file which has words. Let me search for a file. There's a text. Okay, this is also file. Okay, let's give this file as input rather than that. So user you and then where's the file gone? User udp and input. So slash So I'm giving a file which I've just shown it to you, text.txt, and the input and the output directory as dp output. So before that, let me just delete this output directory, otherwise it will give an error. Just give me a minute, let me delete this output directory. Um, okay. So can anyone tell me what is the command which I told you to delete the output directory?
You mean to open it?
Remove, delete it. Delete the output directory. The output directory should not be existing for the program to run.
RMDIR.
Yes, minus RM, and minus R means recursive also. So I can give this also. And minus skip trash I'm giving to just make sure it's deleted permanently and it's not moved to your bin folder. And I'm giving this directory. So I'm deleting just the output directory. And let's look at this file again. Hadoop fs minus cat. This file. So this is the file which we are going to do the word count on. Okay, this is a pretty big file. So let's do the word count on this file, and it will trigger the program. What I'm doing here? /text.text. The output directory would have been created again. I'm just deleting it. Okay, and I'm running it. So at the backend it will run. It will do all the logic which you have seen right now, and it will produce the what is the file name? Text.txt. Text.txt. And it will do all the thing, and we'll just look into the output directory in a minute. It will run. So let it run. Let it give it 5 minutes. Let it run, and then I'll just show you the output, and then we'll wind up for the day. And then you can run these programs and share with you. Try to run the jar also. If you want to create your own jar, try to create your own jar. Try to run them. Try to do as much as what you want to play with, and then we'll be looking deeper into the MapReduce code. So give it a minute. Let it run. So it has ran for us. Now what is the command to look into the directory, to look into that file which has been created by the MapReduce world? Narsimha, you said no or something? I don't know. Guys, you are there with me, right?
It's an output folder. Yeah, it's an output folder.
Minus ls, and then the output folder which we gave. What is the output folder? Where is it gone? User udp output. output, and there will be a file over there, and we'll just look into the file. So the file is by the name of part R. I'll tell you what this file R is. For time being, just get this file. So see, all the words in the file. Now we have the words, and words are also sorted. Why? I hope you understand why. And the counts of the word. If you don't know why the words are sorted, then you have not understood the MapReduce program fully. Well, any question, anything for this program? Or you are good to go?
Good to go.
No? No, nothing? Manza? Looks like she's away. Okay, then we'll wind up for the day. I'll be sharing this code for you. Try to run it, play with it, and then I'll be giving you some assignment in the next class also, and then we'll look deeper into the MapReduce side. Sure, man.
Yep.
Thanks everyone. Thanks for your time.
Welcome. Thank you.
Thank you. Bye-bye.
Bye.